Hello everyone. In this video, we are going to see Born-Haber cycle. Born-Haber cycle is a practical application of Hess law, which states that the enthalpy change of a reaction is same whether it takes place in one step or in more than one steps. Born-Haber cycle help us to calculate the lattice energy of ionic compound. Lattice energy, we know, is the enthalpy change when 1 mole of an ionic compound produced from its gaseous positive and negative ions. There is no single experiment to find the lattice energy of ionic compound, but with the help of Born-Haber cycle, we can construct an energy cycle that help us to find the lattice energies. And for that purpose, we need many different enthalpies. The first enthalpy that we need is enthalpy of formation. Enthalpy of formation is the enthalpy change when 1 mole of a compound is produced from its elements. It can be potassium oxide, sodium chloride, or calcium bromide, whatever they are. The next enthalpy that we need is the enthalpy of atomization, in which we form gaseous atoms of elements. Like we got sodium solid, we can convert it to the gas by providing it with the energy. Similarly, the bromine molecules in the gaseous state can be broken down into the Br atoms. Similarly, chlorine molecules. Okay, the enthalpy of atomization for metals, they are given in the exam questions. While the enthalpy change of atomization of non-metals, we can find with the help of data booklet. So in the data booklet, we got bond energies. Like for bromine, the value for bromine, look at over here, it's 193. So it's half of the bond energy required to convert the half Br2 to Br. So the value for this will be this one. It's a half of 193 to give you 96.5 kilojoules per mole. Similarly, for chlorine, we can find its enthalpy change of atomization using the data booklet. And in this case, since we are breaking 1 mole of chlorine into 2 Cl atoms, we need the bond energy of chlorine, that is 242. The next enthalpy that we need to construct the Born-Haber cycle is ionization energy. So ionization energy involves the removal of electrons from the gaseous atoms. For example, we got sodium, 1 mole of sodium gas atoms convert into sodium positive gaseous ions, and their values, they can be found with the help of the data booklet, because we are given with the ionization energy values in the data booklet. So here we got the values. For example, for sodium, the first ionization energy is 494. So 494 is the energy absorbed actually to convert 1 mole of gaseous sodium into 1 mole of gaseous positive ion. While for magnesium, we are removing 2 electrons. That means we need to add up the first and second ionization energy from the data booklet. Let's see. In Mg, you see the first value is 736, the second value is 1450. So you'll add both of these values to get Mg2 plus. The next enthalpy that we need to construct the Born-Haber cycle is electron affinity. Electron affinity means the ability to gain electrons. Like chlorine atoms, they gain electron and become Cl negative, and in this process energy is released and it may absorbed as well. For example, for chlorine, when first electron is gained, energy is released, but in oxygen, the first electron affinity is negative while second one is positive. So these are the some enthalpy changes that we need to construct the Born-Haber cycle. Now let's move ahead and see a simplified Born-Haber cycle. So let's construct an energy cycle in which we got the sodium solid and chlorine gas. We can convert the elements into their compounds like this, and this conversion, the change of the formation of 1 mole of a compound from its elements, this is known as enthalpy change of formation. So we got the enthalpy change of formation for sodium chloride. This is one pathway. Okay, the other pathway is that we can make sodium chloride solid from its gaseous positive and negative ions. This conversion, it is actually what? It is the lattice energy. Lattice energy is the formation of 1 mole of an ionic solid from its gaseous positive and negative ions. So we got these two pathways. Now there is another one, that is the conversion of sodium solid to sodium positive gaseous ions and chlorine gas into the chloride negative ions. It involves many enthalpies, and let's say we call it right now as the delta Hx. So we got this energy cycle that represents Born-Haber cycle, in which we got two routes. One is the direct route. Okay, enthalpy of formation is the direct route, while there is another pathway, that is the indirect route. Here we got this, in which we can say delta Hx plus lattice energy, that is equal to the enthalpy of formation. So this is the final equation that represents the energy cycle to find the lattice energy of ionic compound. Now let's see more detail of delta Hx. So here we got the same energy cycle. Now we are converting sodium solid to sodium gaseous ions step by step. The first step is to convert the sodium solid into the sodium gaseous atoms, and this involves the atomization of sodium, while at the same time we can convert the chlorine gas into the chlorine gaseous atom, and it involves the atomization of chlorine, and we can find this value from the data booklet. Next is the conversion of sodium gaseous atoms into the sodium gaseous positive ions, and it involves the ionization energy of sodium that we can find from data booklet, while we can convert the Cl gaseous into the Cl negative ions, and this is actually the electron affinity, and this value is given in the question. So we got two routes now. The direct route is the sodium react with chlorine to form sodium chloride. This is the direct route, that is the enthalpy of formation, while the indirect route is sum of all these enthalpies, and this indirect route is like this. So we can say that enthalpy of formation of sodium chloride is equal to sum of all these enthalpies. So let's write this. So we can find the lattice energy of a compound with the help of this equation, in which we have got enthalpy of formation is equal to sum of all the other enthalpies. So this energy cycle represents the Born-Haber cycle. Now let's construct an energy level diagram of Born-Haber cycle using an exam question. So this is an exam question in which we have to find the lattice energy of MgCl with the help of its enthalpy of formation, enthalpy of atomization of Mg, and electron affinity of Cl, and we will use some data from the data booklet. So let's construct the Born-Haber cycle using an energy level diagram. So first of all, we have got the enthalpy of formation, of MgCl solid, and it is produced from its elements. Here we got the elements, and its value is given to us, that is negative 106. So we got first of all the enthalpy of formation of MgCl, and its value is given negative 106. So first step in construction of the Born-Haber cycle. This step is very, very important, because this step dictates the whole cycle, because we use the number of atoms of each type in this formation step, and that number of atoms we carry along throughout the whole energy cycle. Okay, now what we'll do, we'll convert the magnesium solid into the magnesium gas, and this is known as the enthalpy of atomization of Mg. So enthalpy of atomization is given to us. So what we have done, that we have converted magnesium solid into the magnesium gas, and you see in the data we got this value, enthalpy change of atomization of Mg is 147. So this is atomization of Mg, and its value is given 147. Next we have to convert the Mg gaseous atom into the magnesium positive ions, and to convert this we need the ionization energy, and you know ionization energy, it can be obtained from the data booklet. So if you look in the data booklet, The first ionization energy value of magnesium is 736. Okay, the next step is to convert the chlorine gas into the chlorine gaseous atom, and it involves the enthalpy of atomization. So we have to convert the chlorine molecule into the chlorine gaseous atoms. And what we are doing in this, we are breaking the bonds between the chlorine, and its value is obtained from the data booklet, and it is actually the half of the bond energy because it's half mole of chlorine we got. So half of the bond energy, that is 121, is used in this case, and we call it as the enthalpy of atomization of chlorine. Okay, the next enthalpy is the conversion of chlorine gas atoms into the chloride negative gaseous ions, and this enthalpy is actually the electron affinity. And you see the electron affinity is, since it's a negative value, that's why we have made it below. Other values, they are, these were the positive values, so we are making it upwards because these are energy absorbed. This one is energy released, so we have make it downwards like this. So the electron affinity of chlorine is over here, and its value is given to us in this data, that is negative 349. Now the last enthalpy is this one, that is a conversion of magnesium gaseous positive and negative ions into the Mg solid, and this is known as the lattice energy. So the lattice energy of MgCl is this one. Now we can find the lattice energy with the help of this energy cycle, because we got two routes. One is the direct route, this one, in which we are making 1 mole of MgCl from its elements, while there is an indirect pathway. Indirect pathway is this one, that is the sum of all the enthalpies you can see. So all of these enthalpies, they're added together to get this enthalpy of formation. So we can say the enthalpy of formation is actually equal to sum of all these enthalpies, and we can put their values using this cycle, and we can find lattice energy for this compound, and the final answer is 761, and it's negative, that means energy is released. So this is how we construct the Bohr-Haber cycle for the ionic compound to find their lattice energies. So I hope that you have understood all this stuff. So we'll meet in the next video. Till then, goodbye.